Hello everyone, in this video we will learn all about polar coordinate system. To begin with, let's try to compare and contrast Cartesian and polar coordinates. Now take note, using Cartesian coordinates, a point is identified by how far along and how far it is from the point of origin. Now take note, if I'll give this point here, it's located in the first quadrant. So this is X and we have here the Y-axis and this is the point of origin. This point 12,5 here, it implies that the point is 12 units to the right and 5 units up. Now take note, a Cartesian coordinate is denoted by the point X and Y. Sometimes the Cartesian coordinate, it is also named as a rectangular point. Now, using polar coordinates, a point is identified by how far away and what angle it is. So take note, for Cartesian coordinate is how far along and how far up. For polar coordinates, it is how far away and what angle it is. So take note, if I'll have this is exactly the same point with this. But in this case, the point here is, or this point here is 13 units away at an angle 22.6 degrees. So in symbols, polar coordinates is given as r, which is the radius, and you have the angle location theta. Take note of this. This is xy and this is r theta. Now, how to name a polar point? So in naming a polar point, it's very important that you should have a polar grid. So in this case, at the point of origin here, this is considered as the pole. Along the axis here, this is the polar axis. In the polar axis, we can find here different numbers. And these numbers here represent radius of a circle. Now take note, in naming a polar point, it should be r, or the radius, and the angle theta, which is the angle location of the point. So for example, I have here point B. What is the location of point B? Now in this case, point B is located along radius 2 and it is at 30-degree angle. Now take note, if you have a positive angle, you also have a negative angle. So if this is 30, negative coterminal to that would be negative 330 degrees. So point B can be named using this one. Now another way of naming a point is to make use of a negative radius. So take note, this is located in the first quadrant. To identify its negative radius equivalent of this is to identify its opposite quadrant. So opposite of 30, it is here. So it is a third quadrant, 210 degrees. So in this case, the third way of naming this point is negative 2 and 210 degrees. So take note, 210 is a positive angle. You could also have a negative angle equivalent to that, which is negative 2, negative 150 degrees. So take note, if an angle is radius identified is negative, you have to go back to its opposite angle. So that is why if I have a point here, but the angle or the radius is negative, it refers actually to the opposite quadrant. So that's why negative 2, 210, that's actually referring to point B. So take note of that. Now another. Okay, I have here point A, and point A is located in the third quadrant. Radius equivalent for this is at 1, and this is 240 degrees. So therefore, point A is 1 and 240 degrees. Negative equivalent angle to that would be 1 and negative 120 degrees. Now take note, to identify or to make use of a negative radius is go to the opposite quadrant, which is at the first quadrant. Opposite of 240 in the first quadrant is 60 degrees. So that's why it's negative 1. So negative 1 and 60 degrees will always go back to point A. So if 60 is positive, negative counterpart of that would be negative 300 degrees. Okay, one last. Okay, I have here point C, and point C is located in the second quadrant, and it is along radius 3. So with this, point C, positive angle here is 350 degrees, and the negative angle equivalent for this is negative 210 degrees. Now take note, to make use of a negative radius, you have to go to its opposite quadrant, which is at the fourth quadrant. So in this case, this will be negative 3 and positive 330 degrees. So the point here, it will always go back to this. So 330 degrees, then its negative angle coterminal would be negative 30 degrees. So take note of that. Okay, another. Okay, now a polar grid could also have angle measures in radians. So for example, I have here point O, and point O is located in the first quadrant. So in this case, it's located along radius 3. So with this is 3 and pi over 4. So positive pi over 4, its corresponding negative coterminal would be 3 and negative 7 pi over 4. Now to make use of a negative radius, extending this to the other side would be at the third quadrant, so which is 5 pi over 4. So negative 3, positive 5 pi over 4. And the negative coterminal of 5 pi over 4 is negative 3 pi over 4. Okay, one last. Okay, I have here point C, and point C is located in the second quadrant. In this case, it is located along radius 2. And it is at 5 pi over 6. Now, negative coterminal equivalent of 5 pi is negative 7 pi over 6. Now, making use of negative radius, extending this to the opposite angle or opposite quadrant, it is located in the fourth quadrant at 11 pi over 6. So, this is negative 2, 11 pi over 6. Now, take note, negative coterminal of 11 pi over 6, so it's here. So, that would be negative pi over 6. So that's how are you going to name a polar point in 4 different ways. So take note, 4 different ways, but they would mean exactly the same location of a polar point. Okay, how to convert Cartesian to polar point, or from xy to r theta. Now, what is 12, 5 in polar coordinates? So take note, 12 and 5. So here, r here would represent our hypotenuse. So with that, to find r, we have to make use of the Pythagorean theorem. So with this, let's substitute. Our x is 12 and our y is 5. So simplifying, we have the square root of 169, or our radius is 13. Now, to find theta, we have to make use of tangent function. So take note, tangent theta is opposite over adjacent, or that is y over x. So in this case, it's 5 over 12. So looking for theta, that would be arctan, 5, 12. So our angle here is 22.6 degrees, or to be exact, it's 32 degrees. 37 minutes and 11.51 seconds. So take note, in 5 is 13 and 22.6 degrees in polar coordinates. Now in summary, take note, to convert Cartesian to polar is radius is equal to x squared plus y squared, and to find angle is make use of tangent theta, which is y over x. Now, to convert from polar to Cartesian point, that would be r theta to xy. So what is 13 and 22.6 degrees in Cartesian coordinates? So we will reverse the process. So to find x, make use of cosine function. Now take note, cosine theta is adjacent over hypotenuse. So adjacent here is our x and our r here is the hypotenuse. So with this, when you simplify, you cross multiply. To find x, that would be radius times cosine theta. So take note of that. So let's find x and let's substitute. Our r here is 13. The value for our theta is 22.6 degrees. Making use of your calculators, the value for x is 12. Now, to find y, we have to make use of sine function. So take note, sine is opposite over hypotenuse. So opposite of theta here would be y over r, which is r hypotenuse. So to solve for y, that would be r sine theta. Substitute, that would be 13 and sine 22.6. Simplifying, our x here is 5. So take note, 13 and 22.6 degrees is 12, 5 in Cartesian coordinate. Now take note in summary, to convert from polar to Cartesian, x is r cosine theta and y is r sine theta. So take note of that. Okay, so again, Cartesian to polar, make use of the Pythagorean and tangent. And for polar to Cartesian, make use of x r cosine and y r sine theta. Now take note, when converting from Cartesian to polar coordinates, the calculator can give the wrong value of inverse tangent. Now it all depends what quadrant the point is in. Now to fix these things, we have to make use of this. Now take note, if the point is located in the first quadrant, whatever value the calculator will give, you use that. But if the point is located on the second or third quadrant, whatever value the calculator will give for tangent, you have to add 180 degrees. Take note of this. This is for second and third quadrant. Now, if a point is located in the fourth quadrant, add 360 degrees to the calculator value of tangent. Now let's have an example of this one. Okay, convert to polar points. So this is x and this is y. So here our x is negative and our y is positive. So it is located in the second quadrant. So to find our r here, let's substitute. So expanding this, we will have 27. So plus 9, get the square root. We will end up with 6. Now, making use of tangent, it's y over x. Our y is 3 and x is negative 3 square root of 3. Inverse tan to this, we will obtain negative 30 degrees. Now take note, this is located in the second quadrant. So the rule here is, if it's located in the second quadrant, we have to add 180 degrees. So with that, the correct value for theta is 150 degrees. So converting this is 6 and 150 degrees. Now take note, this point is in the second quadrant. 150 degrees is also located in the second quadrant, but negative 30, it is located in the fourth quadrant. That's how are you going to fix that one. Okay, another. Okay, it's negative 3 and negative 4. Convert this to polar point. So first, making use of the Pythagorean theorem, so substitute x and y. So we will have here 9 and 16 or 25. Get the root. The value for r is 5. And to find our theta, tangent theta, this would be negative 4 over negative 3, or that's inverse of 4/3. So negative by negative is positive. So in this case, the answer is 53.13 degrees. Now go back to this one. -3, -4 is located in the third quadrant. So if our obtained value here is 53, we have to add 180 degrees. So we will end up with 233.13 degrees. So -3, -4, it's the same as 5 and 233.13 degrees. Take note, this is located in the third quadrant. 233.13 degrees is also located in the third quadrant. No? So it should always match with each other. Okay, one last. We have here 5, -8. So substitute in the Pythagorean theorem. So it's 25 and 64. So our R here is square root of 89, or that's approximately 9.4. So solving for tangent, it's y over x. So it's -8 over 5. Arctan to this is -57.99 degrees. Take note, this is located in the fourth quadrant. So equivalent to this, we will add 360 degrees. That's roughly 302.0 degrees. So take note, this is located in the fourth quadrant. 302 degrees is also located in the fourth quadrant. So you might ask, Ma'am, -57.99 degrees is also in the fourth quadrant. That's correct. So you can also make use of this. Okay, so I hope this is clear. Okay, next, convert to Cartesian points. So I have here, R is 12 and the angle is 195 degrees. Take note, 195 is located in the third quadrant. So our Cartesian point here should be both negative. So XR, cosine theta, substitute, 12 cosine 195, it's -11.6. Okay, then for Y, it's R sine theta, so 12 sine 195, we will have -3.1. So indeed, it is in the third quadrant. Okay, next, -2 and 60 degrees. So in this case, 60 degrees is located in the first quadrant. But take note, it's negative, so you have to get its opposite quadrant. So still, it is in the third. So substitute x, r cosine theta. So it's -2 and cosine 60, our x is -1. Next, y, r sine theta, so substitute. So simplifying this, we will have -1.7, or this is approximately square root of 3. So take note, 60 is in the first quadrant, but take note the radius is negative. So go to the opposite quadrant, which is the third quadrant. And this points, it's located in the third quadrant. Okay, last. 4 square root of 2 and -pi over 4. So the same thing. So let's substitute cosine -pi over 4. So we will end up with 4. Next, r sine theta. So substitute and simplify. We will have y is -4. Now take note, -pi over 4 is located in the fourth quadrant. And -4 is also located in the fourth quadrant. Okay. Now, let's have this sample situational problem that involves polar coordinates. So take note, let's have this. A surveyor mapping out the land where a new housing development will be built identifies a landmark 223 feet away and 45 degrees left of center. A second landmark is 418 feet away and 70 degrees right of center. 1. Sketch a graph to find the actual angles made by the points and find the distance between the 2 points. Okay, let's sketch this. So let's have this one. This is 418 feet away and 70 degrees to the right of the center. So if this is our center, to the right here is 70 degrees. So take note, this is 90 degrees. So if this is 70 degrees, so the other remaining part here would be 20 degrees. Therefore, the location of this point here is 418 feet away at a 20-degree angle. Take note of that. Now, another given here is 45 degree left of the center. So to the left of the center is 45 degrees, and it is 223 feet away. So in this case, this is 223 feet at 135 degree angle. So why it's 135? Because we'll always start at the positive x-axis. So adding all of this, we will end up with 135 degrees. Okay, now find the distance between the 2 points. Now take note, we will have this. No? So connecting these 2 points here, we're actually forming a triangle in which this side measures 223, this side measures 418, and the angle here is 115 degrees because you have to add 70 and 45. And take note, we have to solve for this side. So in this case, we have here a side, angle, and side. So we can make use of the law of cosines. So we'll have this. So that's 1A, that's from point 1 to point 2. RB here is our R1. So plus C squared, that's R2. Then 2BC, then our cosine A, our included angle is 115. So let's substitute and simplify. We will end up with this. So from P1 to P2, the distance here is approximately 550 feet. So take note as to how it is done. Okay, so that would be all about polar coordinate system. Thank you.